Hello students, in this video I am going to explain applied physics topics for engineering students. Present I am going to deal with unit 2 semiconductor physics. The contents of this unit are classification of materials, basing on passage of current, types of semiconductors, that is intrinsic semiconductor and extrinsic semiconductors. In this p-type semiconductor, n-type semiconductor, and the expressions for carrier concentration. Carrier generation, recombination, band gap, that is direct and indirect band gap, diffusion current and drift current, PN junction diode, its VI characteristics, energy level diagrams, Zener diode, and Hall effect. Classification of materials. So basing on passage of current, we already know that materials are divided into three types: conductors, semiconductors, and insulators. Conductors, these will carry current freely. Like large amount of currents can pass through these materials, because in these materials very loosely bound valence electrons will present. Mostly the metals, they'll contain either one or two valence electrons which are loosely bound to that nucleus, so that they can come out, they can break the bonds within that inertial electrons, and these electrons can move freely from one end to the other end, such that they can carry current. So these free electrons, they'll carry the current in the conductors. The examples for these conductors are copper, silver, gold, etc., and aluminium. Among these, silver will carry current in high quantities. It will have very less resistance. And then comes to the copper. Mostly copper is used in all household purposes. In conductors, as temperature increases, its conductivity decreases, because as temperature increases, more number of electrons will be coming. So as this is the nucleus, this is nucleus, and from the these are the orbits. So the electrons, as temperature increases, the electrons from the inertial electrons and inner shells also, they'll come outside. As these electrons and the free electrons, the more number are increasing, because of these abundant number, they collide with each other. That's why the conductivity decreases in the conductors as temperature increases. Then next classification is semiconductors. In semiconductors, these will carry very small amount of current. These characteristics lies between the conductors and the insulators. That means these won't carry that much high amount of current, and these are also not inert towards the current carrying. These will carry very small amount of current, so their resistivity is very high, that approximately in the order of 10 power minus 4 ohm centimeter to 0.5 ohm centimeter. These will be in a state like these will not act as a good conductor nor a good insulator. The examples for these semiconductors will be the 4A group elements in our periodic table. 4A group elements like the carbon, silicon, germanium. These will contain the 4 valence electrons. 4 electrons in their outermost shell. These semiconductors, they act as like a pure insulators at 0 Kelvin temperature, that is at absolute zero. These act like as an insulator. As temperature rises, they gain that energy and the electrons move to the higher energy levels. So these electrons will carry current. So their conductivity increases with the increase of temperature. So in semiconductors, as temperature increases, their conductivity increases. In semiconductors, the energy band will be similar to like an insulator. That is, the band gap between the valence band and the conduction band in semiconductors is very less, and insulators is very high. That is the main difference between the insulator and semiconductor. Whereas this insulator is our third classification of our electrical materials. So these insulators, they won't carry current at all. Their resistance will be very high at any cost. Mostly these won't carry the current at all. But if we increase the temperature with very high values, but not up to the mark of its melting point, only in the less than the melting point, if you rise the temperature, its conducting property also increases, but not up to the mark of semiconductors. A very very less amount of current will be passing. That too only in some cases, not in all insulators. In very like we can see the dielectric materials as an example of the insulator. Because in these insulators, the valence electrons are tightly bound to the atom. That's why these electrons, they won't come out from that atom. So the current cannot pass in these insulators.